Okay, we've got this example. What would the mass of 50 decimeters cubed of SO3 at STP be? What would the mass of 50 decimeters cubed of SO3 at STP be? You first got to get to moles. Okay, so where are we on our chart? Top, 50 decimeters cubed. You're at volume, you need to get from volume to mole circle. So are we dividing or multiplying? Dividing. What's our formula? Number of moles is equal to the volume divided by 22,4. The volume is 50 decimeters cubed, divide by 22,4. That gives us 2,23 moles. Okay. Right, now we're at mole circle. Where do we have to go from there? To mass. You're going outwards, so you're going to end up multiplying in the end. But our formula, first of all, we need to calculate the molar mass of SO3. And that is equal to 1 times how much for sulfur? 32 grams plus 3 times 16 grams at 48 plus 32. That takes us to 80 grams per mole. All agree? Now your formula says number of moles is equal to what? The mass given divided by the molar mass. We know that the number of moles is 2,23. The mass that you've got, we're trying to find. The molar mass you've calculated at 80. Therefore, we said mass equals 2,23 times 80. And that's going to give you 4. 8 times 2 is 16, and 2 is 18. 16 and 1. 17,84. 178,84. Okay, thank you. Grams. There we go. Everyone happy? Right, the next we want to start off with something, new section of work. It's still stoichiometry, but what we're going to be doing now is called mass calculations. Have you done this before in grade 10? Not sure. Okay, let's have a look. Let's see. If I said to you that to manufacture a cake, okay, put the icing on it. Cake has got a mass of, let's say, 2 kilograms. That cake takes 2 cups of flour. It takes 1 cup of sugar. It takes 3 eggs. It takes 200 grams of butter. And what else do cakes take? Baking powder, 2 teaspoons of baking powder, and 1 teaspoon vanilla essence. Okay, let's not overcomplicate it. That's what your cake requires. 2 cups of flour, 1 cup of sugar, 3 eggs, 200 grams of butter, 2 teaspoons of baking powder, 1 teaspoon of vanilla essence. You whip it up together, put it in the oven, and you'll get a cake which has got a mass of 2 kilograms. Okay. Now if I said to you, okay, that's all very well, you happen to have in your cupboard, you have 10 cups of flour, and you have unlimited of everything else. You've got plenty of sugar, plenty of butter, plenty of everything else, and 10 cups of flour. Could you tell me what mass the cakes would be that you would bake, or how many cakes you'd be able to bake? How do you get 5 cakes? Because you'd be able to get your 2 cups of flour 5 times over, wouldn't you? Okay? Everything else you've got plenty of, it would give you 5 cakes. What would your total mass of baked cakes be? 10 kilograms. Now, we're going to do the same thing with chemicals. It works exactly the same way. So I'm going to give you an example, and I'm going to show you how you go about it. Okay, so let's start off over here with an example. Write it down, and we see what we can do. We'll keep it simple. What mass of H2O can be formed when 20 grams of H2 reacts with excess O2. What mass of water can be formed when 20 grams of hydrogen reacts with plenty, unlimited oxygen? Okay. Now, do you agree it's a similar situation, except instead of giving you 6 ingredients, how many ingredients have you got to make water? 2. You've got hydrogen and you've got oxygen. In this case, which was your limiting factor there? The flour. That was going to run out. And when the flour ran out, that determined how many cakes you could bake. Do you agree? These things weren't limiting. They didn't restrict how many cakes you could make because you had plenty of that. If I said we only had 5 teaspoons of vanilla essence, no, not 5, let's say we only had 3 teaspoons of vanilla essence. We had unlimited baking powder, unlimited butter, unlimited eggs, unlimited sugar. 10 cups. So let's just modify that slightly. And we had 3 teaspoons of vanilla essence. Now, which is unlimited? The middle 4 ingredients. You agree the top ingredient, the flour, and the bottle ingredient, they could be limited. Which one will run out first? Why? Because you're going to be able to run out when you've put together enough ingredients for how many cakes? 3 cakes. How much flour will you still have left over once you've reached all 3 teaspoons of vanilla essence? How many cups of flour would it take for 3 teaspoons of vanilla essence? 4 cups. You'd need 6, so there would be how many cups left over? 4 remaining. How many cakes did we say you would be able to bake with that? 5. What would your 5? No, with this. Let's stop. Stop. Okay. Right. Which are the substances that are definitely in excess? The middle 4. Do you agree? Which are the ones that are possibly your limiting agents? Either the flour or the vanilla essence. If you look at it carefully, which one would you say is definitely the one that's going to run out first? Your vanilla essence is your limiting factor. So this is actually also in excess. You've got more flour than you need. Do you agree? Okay. So How many teaspoons of vanilla essence does it take for one cake? One. And if you've got 3, how many cakes would you be able to bake? 3 cakes, so what kilograms? 6 kilograms. By the way, how much flour would be left over if you've used 3 teaspoons of vanilla essence? How many cups of flour would you need? How many cups would you need? 6. You would have 4 remaining. Okay. Now, I'm going to give you a pattern so that you're not just randomly trying to figure it out like we did here. Okay, because it's a little bit more complicated when you're working with chemicals. You've got to work with moles. The first thing that you're going to do, step 1, is the balanced equation. Let's write that down. Who can give me the balanced equation for hydrogen reacting with oxygen? So it is H2 plus, is it O2 or just O? O2 gives us H2O. Is that balanced? No. How do I balance it? 2 H2Os, because I've got 2 oxygens and only 1, so that, and now 2 H's. Okay, now that's my balanced equation. Okay. Step number 2 is to write down the mole ratio of the limiting substance and whatever is going to form. Now, which is your limiting substance in this situation? Why? Because you only have 20 grams of hydrogen. You've got excess, unlimited oxygen. But your hydrogen is going to eventually run out because you've only got 20 grams of it. So hydrogen is your limiting one. Do you agree? And obviously we want to know how much water you can form, because that's asked what mass of water can be formed. So you're going to write down the mole ratio of that to that. How many moles of hydrogen? According to you, this is a recipe. That's nothing more than a recipe. Who could read that recipe for me? What does it say? Hydrogen plus 1 mole of oxygen will give you 2 moles of water. Right, that's a recipe. So, 2 moles will give you how many moles? 2 moles. If you look at this reaction, it's a bit weird, and people don't always realize that chemical reactions don't balance up like maths reactions. If I said to you in maths, 2 plus 1 equals 3, would you ever have 2 plus 1 equals 2? No. But in chemistry it does work that way because things join together and so forth. Okay? So we're saying that 2 moles of what? Of hydrogen will always give you 2 moles of water. Right. Good. So you've got that. You all understand that? Now, are we working in moles here? Or are we working in another unit? Grams. So convert moles to grams. Okay. So you're going to write down now the mass ratio of your limiting substances. Because you don't have a mole scale in your cupboard in the kitchen or in the cupboard in the lab where you say 6 moles and it says 6 moles. Okay, it measures in grams. So can anyone tell me, how do you convert 2 moles of hydrogen to what its gram mass is? Or where are you on your chart? You're at mole circle. Where do you want to get to? Mass. How do you get from mole to mass? You go down Molar Mass Avenue or whatever it's called, and you multiply if you're going out, or you divide. Okay, what is the molar mass of H2? Well, you can just actually do a little bit of a calculation. It's 2, okay, times 2 times 1 gram. Why have I said 2 times? Because I'm working with 2 moles. Do you all agree? So H2 is 2 times 1 gram. You agree? And I've got 2 H2s. Happy with that? So what is this going to give me? 4 grams. That's the same as 2 moles of H2. What is 1 mole of H2, Jonathan? 2 grams. And 2 moles of H2? 4 grams. Okay. Let's do the same with the water. What's water's story? Okay, how many hydrogens have I got there? 2 times 1 gram plus 1 times 16 grams. Work that out. What's this whole thing come to? This is 18 times 2 is 36 grams. Anyone confused? Anyone want me just to explain again? Let's just have a look at what we've done. What was the first step? We wrote down the balanced equation. In that balanced equation, which were the ones that were important? Hydrogen, because it was a limiting agent. And which else was important? Water. Why? Because that's what you were asked about. Okay? If I didn't ask you to calculate the mass of water, it wouldn't be important. But I'm saying how much water, what mass of water will form. Then you write down the mole ratio of your limiting substance and the important substances. So that's what the mole ratio, you simply copy it from there. 2 and 2. 2 moles of hydrogen will give us 2 moles of water. That's easy. Right? Next step is a little bit more tricky. Now, if you look at a cake recipe, I can give you your ingredients list in different units. I can either say you need 400 grams of flour, am I right? Or I could say you need 2 cups of flour. Would you agree? They may be, I don't know what a cup of flour is a mass of. Let's say a cup of flour is 200 grams. But you agree, you could either state it in grams, or you could state it in cups, or you could state it in whatever unit you want to state it in. And that's exactly the same. 2 moles of hydrogen is exactly the same as 4 grams of hydrogen. So I've just changed my recipe from moles, stating it in moles, to stating it in grams. Who can read this to me? 4 grams of hydrogen, if you can mix it with what? How much oxygen? You've got enough oxygen. Will give you 36 grams of water. Now the problem is, when you bake cakes, do you always use 2 cups of flour? If you want to make 1 cake, yes. If you want to make a half cake, then you're going to use 1 cup of flour. If you want to make twice as many cakes, 4 cups of flour. 3 times as many cakes, 6 cups of flour. So you don't always stick to the recipe. You stick to the same ratio, but sometimes you double up, triple up, sometimes you halve. That's how it goes with cooking or baking. The same applies to chemistry. Did the question state that we were going to use 4 grams of hydrogen? What did the question state? You're going to use 20 grams. So they've stepped it up how many times? 5 times. So now your 4th step is you're going to do a ratio and proportion. Okay, so what did your question state that you were going to be using? It didn't state that you're going to use 4 grams of hydrogen. It said you would use 20 grams of hydrogen will give us how much water? How did you get 180? You said this was 5 times as big, so therefore this will also be 5 times as big. You agree? Great. And if I said to you not 20 grams, if I said 17.24? By 2. By 4. Let's see how you would do it. Okay, let's do it in this way. Let's not call this question mark. What should we call it in maths? X. Okay. We'll give you X grams. Right, and from this we can do our little calculation that says X is equal to, you take the one that you're going to be using, the 20, over what the recipe says you should be using, 4. So that helps you find out how many times bigger that is than that. Do you agree? Okay, so you put what you've been given over what the recipe calls for to find out what the ratio there is. And then you times the 36 by the same ratio. Times 36 over 1 equals, what is it, Luther? What time did you go to bed last night? No, I'm serious. What time did you go to bed last night? Why? Couldn't get to sleep. Why? You need to get to bed in time so that you can concentrate in class. Right, what's the answer there? 180 grams of Does everyone understand what's being done? Anyone confused, not sure? Should I give you another one? Right, this was example number 1. Example number 2. That's a 1. We don't write 1s in chemistry, but if you've got an N2, it means you've got 1. Okay, if you've got more than that, you'll put a number in front of it. Hmm? That's good. Because I don't think that really is the role of the students. That certainly is unity. That links up with that. Integrity is something one could push. Okay, right. Can we do this? Balanced equation, please, Willeng. Right, thank you. Could you tell me, Jacques, which of those three substances, N2, H2, or NH3, which of them are the critical ones, the ones that we're interested in? Oh, sorry, Jonathan. N2, why? You have a limited amount, so I'm going to underline it. Which else? There are always two things. Are we interested in H2? Why not? Excess. Are we interested in that? Why? Because that's what the question is all about. Yes. How much, what mass of NH3? So that's important. Okay, Dylan, can you tell me what the mole ratio of the limiting substances are and the important ones? No, all I want is the mole ratio, please. 1 mole of what? Of N2. Will give me 2 moles of NH3. If I want to write down here, I can write NH3, and this would be of N2. If that makes you feel a little bit more comfortable. Okay? Right. Mika, can you tell me what the mass ratio is?
Mass ratio is on the left-hand side is 2 times 14 grams.
2 times 14 grams. That's going to give you 28 grams of N2. Right. Nikita, can you do the same on this side? 2. That 2 represents that 2 there. Square brackets is the NH3, okay? Yes. Okay, so this is 14 and 3 is 17 times 2 is 34 grams of what? 3. Okay. Luto, how much have we been given? How much is the recipe calling for us to use of N2? No, what is this is the recipe. 28. How much are we using? 5 grams. So are we going to get more, less, or the same? Less. Approximately how many times less? Approximately just, okay, about 5 times less. X grams of NH3. Let's do our little ratio and proportion. I'm going to say 5 divided by 28 times 34 over 1. That is what X is equal to. You agree? And that works out to be 6, 0.07 of right. Can I give you a last example for homework? Quickly take it down. We're already over time. I haven't balanced that equation deliberately. There's your equation for this question. I haven't balanced it. It's your job to balance it. Okay, that's for tomorrow. Do I see you tomorrow? Okay, that's for then. Thank you.